Let's get started. Yeah, it seems like it's recording well. So let's get started. So, I guess we can start talking. Today we will finish this slide, and then we'll for the first half, and then we'll do the Excel. So make sure that you have Excel available on your iPad or your notebook. I mean, if not, then you can do it during the break. I mean, we don't have to use the full-blown Excel. If you access to the web version of a, say, Excel 360 or a Google Sheet would also work fine. So what we cover today is going to be finishing the whole set of slides and then cover some programming. Okay. So very quickly, we just let us review what we have done. Okay. So the reason why we are doing descriptive statistics is the idea that you would do initial analysis on data, right? And then you discover what kind of pattern and what kind of interesting thing, or if there's any problem with data cleaning, and then you would be give you the idea how you proceed forward, right? So to remember, this is the step, right? Because we do get a much cleaner picture of data, and then we can proceed to do some analysis on data, right? Trying to get some pattern, learn something from the data, and see if they can extend that knowledge to say it is going to be true for the things that we don't actually have data on, right? So that's the idea, right? We have learn from the data and see if it apply also outside the data. And the first step is understand data, right? Otherwise, how you can learn stuff. And then the way we do that two way, one is do the visual version, and the other one is the numerical version. The visual version, I'm pretty sure you have learned since you are from the primary school or even from kindergarten, right? So the pictogram, histogram, bar chart, line chart, those. So we're not going to repeat those, but instead we are focusing ourselves on the numerical representation, which are the summary statistic, right? Mean, median, mode, as we learned in the first class. And the second class, we learned range, the corner range variance, standard deviation, right? Skewness and kurtosis, right? And today, after we review, we'll go on to say, talking about covariance and correlation coefficient. Okay, that would be the goal, and then we'll talk about Excel. Okay, so just to quickly remind you that what we have been working on so far are focusing on numerical data, in particular continuous, and otherwise it's not well defined to add things and divide things, right? And of course, discrete also can do it, but there's certain type of restriction, right? When you divide things, it's not unclear, right? Say suppose the number of children of a family is 2.3, it's not unclear what it means, right? But of course, you can say something, but it's not clear. It's never exists an animal or a creature that is called 0.3 children, right? But if temperature applies, then it makes sense to say there's a value that corresponds to the average, right? So that's the idea here. And as I said, I mean, we don't go for the chart and plot, but you should be able to do that, okay, in your projects. So very quickly, again, we go over the what we cover in the measures we cover in the first two classes, okay? So mean, median, mode, just quickly, right? Mean is just average, it's adding up divided by total number of observation, okay? And it's just like the distance from the left and the right are equalized, okay? And the other one we have is the median, which we essentially said this is the one that is in the center or the data exactly middle, right? And exactly middle will be a little bit tricky when you have even number observation where you have to take the average of the middle two. So just to remind you that we do the average because we're in the world where average would make sense. Otherwise, it's better not to report the average, but rather report the middle two guy. That would be more informative, right? So mo is the most frequent one, okay? And depending on how you define, I mean, if everything appear once, then there's no mo. But again, as I mentioned, it would not be an issue. You group the data, then you should then be the modal group will be there. But it shouldn't be an issue because you should be working on data that is more than 10 observation, or you would have. Otherwise, if everything appear once, then there's no point to talk about mo anyway. And we have 5 different measures of dispersion, right? Or the spread, sometimes they call, right? And range is the one that just a max minus a mean, right? The definition, right? And what is the IQR, right? It's best understood from this diagram, right? You have data, you have the median will be just Q2, right? And the first half, you do a median again, then will Q1, right? And second half, you do a median again, will be Q3, right? Then you calculate that directly, right? The IQR will be just the difference between Q3 and Q1, right? But of course, what they do, actually, we do is not do median, all right? Free median, right? We just do a 25 percentile, a 75 percentile directly, right? That is what we do the method 3, right? And that you will see later Excel, they call the quantile exclude, it will be this one. Okay, we'll go over that in the second half of our class today. We'll go over the Excel and then we'll do one by one. Okay, we'll do it. Go over all the function. Sorry, go over all the summary statistics we have say in the class, and then we go over the Excel. How do we go about that? Okay, that will be the one we have. Is this is the one that we will get in Excel. Okay, and next one's variance. Just to remind you, what is this? This is just like the distance from the mean. That is what the meaning, right? Just adding observation, the distance from the mean, you square divided by n. Just want to remind you that we care about the average square distance from the mean in the population, in the whole picture. But to do so, we can't exactly do that. You have to divide n-1 instead. Okay, that is the way that we're doing. And later you will see this is the Excel with the 2 functions, right? The var.p and var.s. That would be the function that we'll be talking about. Okay, later you will see. Okay, and the standard deviation with the square root of variance. Okay, and you have the stdev.p and stdv.s will be the 2 Excel function for these 2. Okay, that's we will do later as well. Okay, and this one is just the division, so you should be able to handle that fairly quickly, right? And this is the one I want to talk a little bit more because this is thing I suppose you haven't learned from your high school or haven't ever seen this before, just to give you more idea, right? And this one, okay, is trying to measure the distance from the mean. I guess we can close the door. Is looking at the cubic distance. To remind you why cubic is, then the negative will remain negative, right? It's different from square, right? You may consider why we don't use the other thing, right? Because if without square or without cubic, it is 0, right? The meaning of mean is actually this guy is 0, right? What I'm saying is looking at the numerator, right? Without this is 0, right? Because that's the meaning of the mean, right? Exactly the center. So adding all distance will be 0, right? If you're square, the problem is, as we know, right? Square everything will be positive, so cannot represent that. But if you have raised to the power 3, negative remain negative, positive remain positive, right? And same as square, the further away from the mean, the value will be larger, right? Consider the case 10, right? 10 times 10 times 10 is 1,000, right? It will be a very large number. Compared to case of 1, is 1 times 1 is 1, right? So the further away from the mean will be magnified so large, so that if the shape is so asymmetric around the mean, that will be maximized, right? Will be reflected into this one, right? But the reason why we want to divide by the standard deviation cubic, one thing is to make the unit the same. Second is we want to isolate our measure from the spread, right? Because you don't want to affect the skewness by spread, right? So that's why you divide by that, okay? And the measure, okay? And later you will see this is the skew.p, okay? Will be the Excel function we will use to calculate this, okay? Skew.p. We will have that. Don't worry, we will have that after the break. Okay, we'll go over that. And this one will be actually Excel will just skew. Okay, and actually you will see it. The skew with the one you input the data, put this function in, then give you exactly this formula. Okay, so that would be the idea behind how we do Excel. Okay. So just to have a good idea, okay, of what skew is 0, positive, negative means, okay, we give the simplest example that you hear, right? If they are 0, it means symmetric about the mean, right? I think you learned symmetric in your primary school, right? Just like everything here the same, right? You can go for both sides, right? Look at the side symmetric, right? And in the case skew or positive, in this one, it's a good figure, okay? And you wonder why this is positive. One idea, the mean is here, okay? And this value far away from mean, right? Compared to this, there's nothing here. And this raised to the power 3, right? And this thing, right, make the number very big, right? And you raise to the power 3, then it will be very big. So that's why this end up positive, right? So that's why it look like this. So that's why people would call this positive skew or right skew. I mean, because right is the positives. We draw the number line in this way, right? And usually, not always, when we have positive skew, it usually we have the mean bigger than median, okay? And the most common example, probably you would guess and we would see, is the income data of an economy where you have small number of people earning so much compared to the rest. That is what you observe, okay? So that is something when you learn statistics, this is people quote this. So okay, right? So another example probably might be true. I don't know, but probably you learn the recent news of the, is it JPEX? JPEX, right? And going to be likely, I don't know the truth, but you will imagine some people make so much money and many people making losses, right? Or something like that would happen, right? Or even in general, right? Doing the cryptocurrency thing is like all the same, right? It's like a bunch of people make, I mean, even the stock market the same. In the stock market, you look at the data. I mean, some of you may be a very good trader, but on average, most small trader, individual trader are losing money, right? And only few guy, very smart guy making money. Maybe you are the one of smart guy, right? But it would be or the casino like this. Right? Casino will be, or doing the lottery ticket, Mark 6, the same thing, right? One or two people would making the big first prize, but most people are losing money anyway. Okay, so that is the thing. It's not abnormal to see this type of graph because it's very common in our society, right? And negative is the other way around. It's just like let's say some people pretty miserable in some sense, right? And that happens when you sometimes have some selection, right? One example probably you will be familiar, would be the GPA of our B school, right? Especially you are in the elite faculty, in the elite department, right? Some of you are quantitative finance, some of you are accounting, some of you B.B.A, and so on and so forth, right? Pretty good. So when I have exam or test or assignment, that's very normal that I have a lot of people actually doing here very good, doing A and A minus, B plus and B and C, something like that. Okay, it's very normal, natural. I mean, throughout my teaching career in Hong Kong and Singapore, it's very normal. You see this kind of style, because you are actually being selected, right, into CHK, into the B.B.A program or the other business school program. Then you are best, right? One of the best, among the best, right? So that would be, this would happen. Okay. And want to emphasize this is skewness actually carry premium. And some of you may learn finance and you would know the current regime is people talking about mean and variance, right? It's talking about return and the risk, expected return and the risk. But these days we know skewness actually pays, right? People would try to think if the stock is likely to be making a lot of profit, although the profit is not high, you would do it, right? But it's not surprising, right? You buy lottery ticket, right? People buy lottery ticket. People go to casino, right? Then that's the case, right? Next one is kurtosis, right? Kurtosis is replacing the skewness from 3 to 4. Okay, that's the formula. And actually, you can imagine that has some flavor of skewness, right? But the skewness would cancel out positive negative. So it cannot tell you the extreme values are, right? So if you, because now we care about whether both sides of the extreme value, smaller negative below the mean, above the mean, are they very big, right? And this is kurtosis, right? And of course, some of you, if you are no math, right, then you would ask why we just stop at 4, right? Why not 5, 6, 7, 8, 9, 10, right? There's no stopping. Yeah, you can, right? 5 is also a measure of skewness, right? 6 is also a measure of kurtosis. That's fine. There's no problem. But that is the thing we use, right? And then why you ask this, why this is not a spread, right? This also can be used as a spread, but this is the way usually we do, okay? And the kurtosis is trying to see this one. And why this is a good measure of the spread is because usually we compare it to the bell curve, which is 3, okay? If you look at the bell curve, which is called the normal distribution, and it's 3, okay? And probably you just want to ask what's the bell curve. We will talk about this in the topic 3, but the idea is actually very deep because this is related to one of the most important theorem in statistics. It's called the central limit theorem, which essentially said if looking at the things that is coming from effects of many small stuff, small process, okay, then that thing come out to be normal, And that's why you see so many things normal, right? The IQ, the height, the wage, the rainfall, number of typhoon. Then if you think everything is more or less random, then it's coming from many things, then it's likely to be normal. And since normal is so common in the natural environment, okay, then we would think something more than the natural environment will be a big tail. And most of the classical analysis in statistics is focusing on by studying the nature, right? You know, right? And that's why the tools that we develop, right? Normal is so common. That's why when things is fatted, have a fatted tail, then normal, we have to be careful. Okay. Just to remind you, what do I mean by fatted tail is the blue one is the normal curve, the bell curve. And if you have the tail area is higher than the blue one, that are red as red do, then you should ring the bell. And the thing we usually do usually doesn't work that well. Okay. But I just stop here because we don't have time to study what happened if the fat tail, but just let you know what it is. Okay. And this is the function. Okay. And Excel, we don't have this guy. Okay. But Excel, we have the sample counterpart that is coming from Excel. Later you will see it's called curve. Okay. This is the one that we will be using, right, in Excel, right? So we'll work on that. Okay. And I guess I have already discussed why we care about this, right? Because kurtosis, you want to care how bad are the extreme value, and then if interested, you can go on. But for those people who working in finance, then you should be worried about your data, right? If the data, the stock data, history, stock price data exhibit very strong fat tail, then your calculation should be more careful. You should worry about the value at risk you're doing. Is it 5% enough, right? Or something else. Okay, but that would be something that you might have to take into account when your data show excessive fat tail. Okay. So now I want to divert your attention to the following. So far, we have been talking about a single measurement on each observation, right? We're looking at IQ by itself, height or weight by itself, okay? But we are not talking about how they're related somehow, right? Suppose something that would concern you is after 4 years in CHK, or 3 years as well, depends on who you are. And you would be thinking whether you want to study more for the master program or go to overseas and so on and so forth, right? Or even much more pressing issue would be, do I want to study for the stat class, right? Right, it's very boring topics. I'm not using stat anymore, right? Or in particular class on study, right? So you want to see whether, if you care about money, I suppose you would care since you're business school, then you want to see if your GPA actually would affect your income, which is your wage, first monthly wage of the first job, right? So what you're going to do is to collect the data for each individual, right? Your 2 data point, right? You ask, what is your GPA and what is your salary of your first job, right? So instead of asking the GPAs for everyone or income everyone, for every individual, we have 2 measures. One, say GPA, the other is his wage of the first job, say, right? There's something you care, right? If then the question is, you want to study how they're related, right? Are they positive related, right? If positive related, then you should study more on the stat subject, right? Because that carry 4 credit, right? You know, from the weighted average, you should study stat rather than subject that have 3 credit. I mean, if you have 1 hour to spend, right? Where you could spend, right? And if it's negative, what should you do, right? You should go out and play, not doing any study, right? If negative related, right? So that would be something that can explain your action, right? Or the question would be, a pressing question would be, you are a marketing manager or department head of the marketing of a company, right? You want to ask the CEO or the management, please give me more advertising budget. It will be helpful to boost the sales, right? We should have, say, higher, I don't know, what's the name of the very famous singing group these days? What? I don't know. What's the name? I don't know. I forgot the name. Huh? You don't know? Who knows the name? I don't know because I just come out. Famous Hong Kong, yeah. Mura. Yeah, Mura. Hey, sorry. I just forget the name. Mura, yeah, Mura. Or Era, I don't know, right? Or I don't know, there's some famous guy, right? We want to hire a famous guy, right? To sell the product, right? And then how can you justify the budget, right? How can you say, why we have to hire that guy, right? Why don't we hire another guy, right, to do it? So then the question would be, you would try to convince your boss by showing that whenever you spend more on the marketing, the sales goes up, right? That is how you convince, right? So, and the way you do will be, we were doing a scatter plot as a graphical presentation, right? But you need to quantify it, okay? The way to quantify the relationship between 2 variables will be what we call the covariance and correlation coefficient. That is what we do, right? We want to tell our boss, okay, spend more money, we sell more, okay? So that's the idea. Okay. Or you want to convince your daddy and mommy to pay more for your master degree, right? How can you justify that? You should tell them, okay, if I do 1 year MBA or master, I earn more, right? So that is the idea. Okay. Now, the idea is the following, okay? We will use the concept of the quantifying, is called the covariance, okay? By the name, you can imagine covariance should be following what we call variance, right? Because it's covariance, okay? So you should expect the formula would be very similar, as we will see here, right? If you remember, our variance about x will be this guy, and we got a square here, right? That would be variance on x, right? If you on y, variance on y, okay? So what does that mean that why we have a multiplication of the x minus the x bar and y minus y bar? What is it measuring? Okay. So let's see a graph, what is called scatter plot. Will give you a very clear idea what we're doing here. Okay, just to bear in mind, is multiplication of the 2 number is distant from the mean. Okay, so let's do this, what we call the scatter plot. Okay, this is scatter plot usually you use to present your data. Okay, so how we do that? Okay, what is this graph is? First is X, suppose X is the, as I mentioned, this X is like the GPA, right? And Y may be income, okay, to make you familiar, right? And maybe the average GPA is 3, right? And average income, I don't know how much we are making, but let's suppose 20K. Oh no, that is the average income, not the graduate, right? Maybe, I think according to the standard, right, 50K is the normal for the full-time graduate, right? So I don't know, I just make up the number. Anyway, I don't know the data, but let's make it true, okay? So what happens if your GPA, what does this data point means, right? This data point mean is that guy GPA is 3.1, right? This guy is making 60K, right? So that's the data. With an individual, we talk it is he's making 60K and with GPA 3.1, right? And what happened to the other data point? This data point probably is this guy, is 3.2. Then he's making the 58K, okay? So and so forth. So each point in this scatter plot will present a data we have is every observation from X and Y, okay? We have their GPA and their income, okay? And in this diagram, even though without math, you will see the higher the GPA, the higher income, which is not surprising, right? But we want to quantify this one. And how do we quantify this one? Is to compare each observation to its mean in 2 dimensions, and then see whether they are above the mean together, okay? So let's see it. First, look at the first data point, the purple, the pink one, all right? So you can see this individual, his GPA is above the mean by looking at the horizontal, right? Because GPA look at horizontal, right? This is positive. And his income is also higher than the mean, right? Making 60K compared to 50K, right? So, and remember the formula, we multiply this distance, okay? We multiply the horizontal distance and vertical distance, and they are positive, right? And you can do the same, and you can see whenever the data is on the northeast part, right, then it's positive multiplication, right? So remind you that, right, this is the point where you have X bar, Y bar, right? Anything that is in the northeast part of this X bar, Y bar is going to, the product is going to give me the positive, right? And anything is on the southwest part, the blue one, everything is negative, right? So if all your data is fall belong to these 2 regions, it's positive, right? Add them all up, it's again positive, right? So the more data in here, right, the more positive you are, right? And you can easily, without looking, or just imagine your data is here or there, okay, on the southeast or northwest, sorry, north, yeah, then these 2 are negative. Why? Let me show you the next slide, right? The reason is being that all this data, right, when, say, this one, when Y is above the mean, but X is below its own mean, right? So this case, negative, right? The multiplication negative, same as here, okay? So it would clearly show the covariance idea. When it's positive, they are positively related. When they're negative, they are negatively related, okay? So that's the idea. So let's go back. Let's go back to here. That's the measure, right? It's looking at the product of the distance, right? above the mean, right? If they both above, they move together. If below, they negative, they are opposite. Okay? So that's the idea of the covariance, right? And again, we have the same idea of the variance, right? You have to choose n-1 when you do the data. Okay. So for the Excel, you will later see this is the what we call covariance. Covariance dot P, and this is covariance dot S. Okay, we will go about that after the break, but that's the idea. Covariance. Okay. So just to repeat, okay, if they move together above the mean, most of the time it's positive, right? If it's negative, right? Because you will never have a data that looks that nice, right? But you have data sometimes negative, sometimes positive, but on average it's positive, then it's like they tend to move together, right? Because data never perfect, but that's a good measure. Is that okay? Now, no question. Then we come to the very last measure that we learn in this class. It's what we call the correlation coefficient. So don't worry, this one is super easy. Okay, this one is trying to make our covariance more accurate in the sense that we will make the covariance always fall between -1 to 1. Okay, why we do that is to normalize the thing when we can compare different across data set, right? So what we are doing is, here is we have the fraction again. The numerator is the covariance. The denominator is just 2 standard deviation, right? This is SD, right? SD of Y. This is SD of X. This is covariance XY, right? So that is what we have, right? The numerator is just what we learned, and the denominator are the standard deviation of the two. Okay, so of course you can write in this way the same thing. Okay, so probably not entirely clear what it is, but let's see. Okay, very simple. The reason for this becomes -1 and 1. If you learn M2, that is from the DSME program, that is just applying standard quasi-Schwarz inequality. Just say less than 3 steps, you are done. But anyway, we're not math class, we're not proving it. Okay, if you're interested, you can check it out. It's very simple proof. Okay. Anyway, so this is the idea. Okay, if it is 1, everything fall into a line. Okay, so the perfect thing you get, right? You get 1 more X, you get some more Y that can't remain the same. It's positive. It's exactly 1. If positive, it means it follow in this way. It's not perfect, but it's positive. Okay, of course, the closer to 1, the better, right? This is pretty close to 1, and this is 0. Okay, what do we see here? What we see here is, even if you tell me what the X is, okay, you can't tell me what the Y would look like. Or reversely, you tell me your Y is -1, do I know anything about X? I can't, right? Giving you anything about X cannot tell me Y. It's like when you have 0, right? Say if they're not related, then I tell you a guy have GPA of 3, you can't tell me the income. Or GPA 4 actually can't tell you the income, right? And if what we have the data is like this, right? Then they're negative related, right? And if -1 is exactly like this, okay? So there will be, everything will be fall between 1 and -1, okay? So probably you still would be asking, what would I say the two variable related, right? Because it's just like 1, of course, is good, but what about 0.9, 0.8, 0.7, 0.6, 0.3, 0.4, right? What you do? Okay. Usually, we would be saying that there is a relationship if it is 0.6 or above. Okay, if 0.5, 0.3, 0.4, yeah, they're positive, but we would not make any claims on it. Okay, we would be start to making some claims if more than 0.6, right? 0.7 will be worth looking, right? And 0.8, 0.9 will be strong. Okay, of course, 1 would be super strong when we never exist anyway. But at least we would say 0.6 above, there will be something we would be happy to say something. If 0.5, we will not say they're positive. It just happen to be there, right? Unless you have a lot of data. Okay. And since we're talking about the line, okay, actually one of the big things we're doing for this course is trying to have a line. How do we draw the best line to present data? That's called regression. It's our last topic. We're doing is given this kind of data, okay, how do we draw a line to represent the data? Okay. So you may ask, okay, that's easy, a line, right? But that represents a central concept of statistics. We have a bunch of data, which is a rather not informative, right? But we condense our knowledge of data into a single line, okay? And that line can extend our knowledge from data to many, many scenarios that we don't have data on. We can extrapolate or interpolate, right? Then that's how we learn, right? That's actually how science, right, and engineering do, right? Do different experiment and see the things work, and then we collect the dots, right? So that was the main thing. And in this class, we only learn how to do it when we have y and x, right? Only y and x, and draw a line. But when you go to further 2021, I think, right, the advanced class, you will not draw a line, you draw a plane. You consider 3-dimensional plane or n-dimensional hyperplane. So you'll be fitting a very complicated model. And suppose you want to learn analytics, you want to do machine learning, you want to do AI, actually, you see those of things are just like more complicated fitting line. Okay, of course, they are much more advanced, but at the end of the day, it's actually doing lines, right? But of course, the complicated one is not in line, maybe a piecewise curve or more complicated thing, but at the end of the day, it's like that. Okay. Any question? Sorry, a little bit overrun, but let me finish this final slide. This one is the sample version, right? Because you would ask, we have so many sample version. Do we have sample version for this one? Turn out to be, luckily, the sample version is same as the population version. So we just can go ahead to estimate what we want, we find. Okay, so the math, the proof is here, but I'm not going to go to the proof because no one cares about proof, right? Anyway, in this class, I mean, maybe except QFN student who should or look at the proof because they would be doing the proof in the future. So, but I just left here. Okay. Now, if you don't have anything to ask, let us have a break. Now it's 10:19, so we will resume at 10:44. Okay. So I'll go around to every question to make sure we'll do Excel after the break. So make sure that you have your Excel on or your Google Sheet on. We'll go over those. Okay. In the meantime, if you have any question about the slides or the problem with your iPad, laptop, let me know. 教完咪用咯。你唔帶得嘅，你 iPad 得㗎。我哋教到邊度咪教，你知道。我冇得好大講都。 So get your Excel ready. Hi. Oh, I forgot to say. If you are a very good user of Excel or you are using Python already, you can go home now because there's nothing you can learn from this one. Okay, because we'll be assuming that we start from the scratch. You know nothing about spreadsheet in Excel. Okay, so if you already know Excel and you think you read the slide, you know it's no problem, then you can just go home. Okay, there's no need to stay. Okay, because don't waste your time here if you know. Okay, just go home, do your business, and have fun. Okay, see you. Okay, so if you know, it's fine. Okay, because start from scratch. But I think many of you already know, so that's no problem. But we start from the scratch, assuming that you don't know. But if you work already, then there's nothing to learn. Okay, so Excel. So we get start. So let's open Excel, or we can also show you the Google Sheet, also the same. Okay, but we just do Excel because that's the same function. Okay, just to remind you, if you already know Excel, you can go home. There's no need, no extra gain from this one. Okay, and with Excel here, so what we can see here is a spreadsheet. Okay, so this is the thing we're working on. So some of you may have worked on the worksheet or not, but this is the thing. Actually, my first intern when I do it. Oh no, my first intern is just a photocopy machine in a back office. But the second job I do is actuarial intern, and what I do is actually fighting for this for the whole summer. Okay, and of course, I think now everyone now using a more specialized program. Probably Excel is no longer a big thing, but still for our class we do Excel because other class do Excel as well. We can cover Python, but if you know Python, then everything what we learn is very simple as well. So it's nothing deep in our class. But just we do it because just make sure that everyone is on the same place and we know how to use Excel to do what we want. Okay. So the first thing here we want to cover is the spreadsheet, right? This is the thing we do, and everything you can see is a spreadsheet, two-dimensional grid, right? And the columns are by letters and the rows are by numbers. Okay. And the first thing we want to talk about is how to use, how to enter the basic thing, right? So that's why we quickly go about is we do a calculator as we do the slides, right? We do calculator. As we will start with the equal 1 plus 1. This is the thing we do at the very basic thing, right? It's not hello world, sorry, but we do Excel, we just do calculation, right? This hello world command, okay? It's equal to 1 plus 1, okay? So to show you one of the very important function for teaching Excel is to what we call a function called formula test. Okay, a formula test. What I do here is I will try to show you what is the input. I put in A1. You don't need that for your computer, but I just here to show that this is what I input. Okay, and do remember when you do calculation, okay, you have always put equal, okay, in the formula, right? Because otherwise it will consider as a letter string. Do not do any calculation. When you need Excel to do any calculation, you need to put equal, then you do calculation, okay? Now, very quickly, we go to the basic or the operation, say minus, okay? I will do multiplication very quickly, okay? And we will do multiplication, and we'll do division, okay? We will do raised to the power, okay? So these are the operation that we'll be working on. And I just go around to see if you have any questions setting up your stuff, because it's very simple. I hope there's no problem, but anyway, starting up is always a problem. If you have your iPad, you have A on, notebook A on, or you can, even your cell phone can make it work, okay? I know everyone knows it. I mean, of course, for expert, then you can go home. But otherwise, you can stay. I mean, you're welcome to stay, but I mean, some of the expert already go home. So, you know, then it's nothing, okay? Okay? Now, the next thing I want to talk about is the function, right? Actually, we have seen the formula test, okay? What we're going to do is Excel has a lot of function there, okay? And probably we can see it here as well. Excel actually called formula here, okay? And you will see that, sorry, what happened? A large number of formula, you can easily take it out, okay? And there's a lot of function, but you can just click and you can see there's so many functions here, right? And of course, what we will learn in this class will be statistics. That's something we will learn. We will learn not all of them, but you should be able to understand most of them after this course. It's one of the goals is to understand all the statistical function from Excel. Okay, and what we're trying to show you is some of the function we use in the math, because you know we'll use some of the function here because they will be used. The first one we're going to use, maybe I just continue this one. It's called function, and then we will do is equal, because start from equal. We'll do the square root. Okay, this is the function that we are using. It's called SQRT, and do note that the way that the Excel, when your function, you always do the capital letter. Even if you type small letter, you convert to the capital letter. This is the latest function in Excel. And I think also Google should also do the same. Okay, so the square root function is something that you can use. Okay, if you don't know, then this is here. You can go to the square root. Okay, is it here? Yeah, here you can check the thing, right? Return the square root of a number. Okay, so that is the idea. Is that okay? Of course, there are many things you can do, right? Say, for example, the thing we said in the class is run up and run down, right? It's the floor function and the ceiling function, right? So let's do it quickly. I do the run down, 3.1 and do 0, okay? And what you get is a floor function, right? If I have run up for 3.2, oh, sorry, and then you got a 0 digit because you want to run it to the integers, okay? So that will be 4, okay? Don't worry, I'll upload this Excel on the black box so you can take a look, okay? So if you are unable to get this guy, let me save it. Bear with me, I'm sorry, I just save it on a desktop first, okay? So if you cannot follow, you can, I will upload this video, right? You can check the video again, or you can check the slide again, or you can check the Excel sheet again. So these are the functions that actually cover, right? So that is how, if you have number, how you can operate, right? Is that okay? Round up is like you go up, right? 3.2 become 2, right? Round down, you just take away. Is that okay up to now? Is there any question? Because we just try to start from very basic, assuming you have no knowledge about programming, because we're not programming class, right? But just make sure everyone on the same page. Good? So, and now the next thing is trying to put it a little bit further. I'm going to do it is continue to go on is using the basic function input data. Okay, to input data in Excel, you have to use a bracket, curly bracket. Okay, so let me do the very basic function we call counting. See how many of the observation. So we will do the function called count. That is, as you can see, probably you can't see from the back. It's just like how many numbers are there. Okay. So suppose I have a count and you do the curly bracket. For the curly bracket, no matter your window or Mac, is next to the letter P. Okay. Letter P. Okay. Curly bracket, and you put say 1, 2, 3, 4, 5, 6. Okay. And by construction, you have 6 observation. So this would give you 6. If you try to, let me do the entering. Okay, because 6, because that is the Excel will tells you how many numbers are there. There's 6 numbers. Okay. The next thing probably you would see, right? You would guess is if another function that's very important is the sum. Okay. You want the sum 1, 2, 3, 4, 5, 6. Okay. And this is 21. Right? So if you're aware what I'm doing, I have a row number 10 and row number 9. We have sum, we have count. The fraction is average. Right? So if I want to do the average, right, then I can do, right, I can do the sum, right, 1, 2, 3, 4, and 5, and 6, right, and divided by count, right, and we do 1, 2, 3, 4, 5, and 6. Okay, so that would be the case. You get the mean of 3.5, right? So that would be the way that you would start from scratch, right? But we know, actually, you should see for every stat function, there should be something you can find in Excel. Okay, so actually you can do what we call average. Okay, you don't need to start from scratch. You can see I do the average, the function called average. Okay, sorry, average. Okay, I put 1, 2, 3, 4, 5, 6. Okay, and then we have that. The same thing here. Average give you the average of the inputs. Okay, so that is how you will learn. We cover all the function. Okay, about the thing we learned. The average is the mean the class. mean is the same as the mean. Okay. So is that okay so far? Let me go try to see if you have any question. Yes. 我後面呢個我 create 出嚟係個 formula test 係可以顯示我打咗啲乜嘢嘅，你唔需正常係冇嘅。你要多個花括號先得，你留咗個花括號。如果唔係佢 ，so you have to make sure that you get the curly bracket between your data, otherwise it doesn't work. Okay, is there any question? I just try to see if any. So today's spreadsheet is slightly different from yesterday's one, but I mean, well, every time a little bit different from teaching, right? Just like you go to concert, right? The record is different from the real time, so it's slightly different. I mean, but I mean they will be the same, similar. Okay. Now the next thing I want to talk about is you can see every time we input the data is rather time consuming. It's always a hassle, right? So that one thing is I mean, if you don't do this, is numbers here, right? So you want to do several things. One is to separate the data from the formula, right? To take it out, I mean, I want to see the data, right? This is rather clumsy. So what to do is what we will call, if you learn software, right? It's called self-reference, or we call variable approach, right? We store the data in somewhere and we apply the function to the data, right? Very standard thing. So what we're going to do is open a new spreadsheet, or you move to somewhere else is fine. I usually open a new one, okay? And what we're going to do is, usually the standard way I do is I store my data on a column, okay? I will start typing the data here, okay? And I don't have equal sign here. So that means that Excel will consider this as a text input, okay? Don't do any operation, okay? I do data here, okay? Here I have a spreadsheet, okay? I use the plus sign here to open a new one, okay? And I put the data here. Maybe I have 1, 5, 3, I don't know, 8, 10, 12, something like that, okay? This is data, okay? What I'm going to do is do the same thing, calculate mean, median, mode. That would be what we're doing here, okay? How do we do that? Maybe I put the mean here. I type here mean, median, and mode. For mode, maybe I just change a little bit to make the mode exist, okay? So this is the data I have, okay? That's the type thing you type, okay? So here I have the data putting in vertical line, but you can do it horizontally, that's no problem, okay? That's no problem, but I just put it there, okay? Or some people would put the data in one sheet and calculate on the other, that's also fine, okay? But I just make our life easier, everything in the same spreadsheet. Is that okay? So how to do mean, okay? Since the data are here, you just need to tell the software where to get your data, okay? So remember the function is what we call, it's called average, okay? Average here, average, okay? And then you have to tell them from where to where, right? From here, it's like the data is A2, A3, A4, A5, A7, A6, right? Because we just call it by the name of the column and then row, okay? A2 is the number there. So you can just put A2 and then up to A7, okay? And the shortcut to this in Excel is you can have a colon A2 and colon A7, okay? So you can all even see Excel very clearly, show you the blue area. This is the area that the data comes in. Is that clear? So this is how you would do it, okay? And once you do that, that's there, okay? So that is what I working in, okay? This is average. The next thing I want to show is median and mode. That should not be too much difficult. Median is just median. Okay, median. Now, instead of typing, if you use the Mac, iPad also can do it, is you can use your mouse, okay, to highlight. Okay, you just click A2 and drag it to the end and release your mouse. That gives you the whole range. Okay, so that is how you do it. Okay, so then once you're done, you close the bracket. Of course, you can always type. You're done. That's what I'm doing here. Yeah. Okay, that's median. Okay, that's how you calculate the mean, median, and right. And one of the good thing about you write the data is A2 to A7 is if you change the data, everything changes automatically, right? For example, if I change this to 2, so you can see everything change accordingly. Of course, the median is not moving, but you know what's going on. Is that clear? How we handle it? Okay. Is that okay? So we'll go to the mole, and for the sake of simplicity, we only focus on the case where you only have single mole in the data. If multiple is a little bit more complicated. Even if you look at your Python code or our code, looking at the mole is slightly you need some coding. Okay, unless you define it. I mean, naturally, it's no natural way. So if single mole, Python we can do it, but multiple mole is slightly difficult. So we do the single mole. Single mole, the function is just mole. You can see the multiple and single. I'm not going to talk about those, but we focus on a single case. If you're interested, you can figure that out. It's single mole. Okay, in this case, apply because we have obviously have one that appear. Okay, so I just click and drag. Okay, and do this, and you give me 10. Okay, so we have mean, median, mole. Okay, is that any question? I hope you can follow. Of course, those who know should not be an issue, but I just follow the single mole. Okay, if multiple mole will be more complicated. It's require array function, so I'm not going to talk about those. It's beyond our class. Okay. Oh yeah. So I've seen some of you. There's slightly typo in the slide. This should be the geometric mean, harmonic mean. The one in the blackboard is updated, but I noticed this is something I make a mistake here, but shouldn't affect you because we're not talking about those. Okay. So for those you don't you can see the Excel slide have many stuff, so don't worry. We only cover those we think important. The rest is just for your reference. Okay, and you just need to know the things we cover. Okay, I mean I put it more because depending on time in the class I cover more or less, so it adjusts accordingly. But I think I just keep the thing that is important. Okay, so next is about range. Right, we finished the central tendency with dispersion. Range is what? Unfortunately, there's no formula directly, so we have to calculate the maximum and minimum. Okay, luckily Excel have the thing called max and mean that we can do it. Okay, so range. Then, but before we do it, there are two ways to do it. One is directly. Okay, we can do the following. It's just max, right, minus the mean. Okay, why is not? It's weird. Why? Okay, so this is how being done, right? You can see 12 minus 1. Okay, this is right. This is the range, max minus mean. Is that okay? Of course, if you want to, sometime if you don't want to do that, you can do the several part. You can do the max first. You can do the max first. You can do the mean first. Okay, something you can do something like this. Max is equal to this. Okay, and mean is equal to this, okay? And then you can do the range again, okay? How you do that is just from the D6 minus D7. So this is how I do, okay? Sometimes you want to do, let me yellow this out, okay? Sometimes you want to do it the yellow way. And actually, I recommend it you do it the yellow way and then the other way around. The reason being that this is more transparent compared to this guy, right? This guy will look at the formula and see what's going on. But this one is very clear what you're doing, okay? Unless you are super sure what you're doing, I recommend you do it step by step. Same as all the programming, right? You can solve it in a one single elegant code, but now the computer is so fast these days, there's never a bottleneck for the most application. So I recommend you do step by step, if possible. Okay. So then next is I want to do the IQR, and unfortunately there's no IQR thing, so we need to do Q1 and Q3. Okay, we need to do one Q3 before we can do IQR. So how to do Q1 and Q3 is, as I mentioned, you have a quantile exclude, okay, quantile EXE, and probably you will see quantile included, but that will be another thing. But we'll focus on this one, quantile EXE, okay, and the data is from A2 up to A7, okay, and what we want is the two argument here, quantile, you have to tell them is Q1, right? This is data, Q1 is 1, okay, Q3 is 3, okay, you have to put a comma and 1. So this is the formula. Quantile dot exclude your data and 1. If you want Q3, then will be 3. Okay. And then I left you an exercise for 5 minutes to IQR by yourself. Okay. Using the technique we learned, do the IQR for me. Okay. I go around to see if any question. I give you 5 minutes to do it. Because all the experts are gone, so we can do tutorial style. The question asked me, remember it's quantile dot exclude, okay? So if the question asks me, I go around to check out if you have any question. So please do the IQR for me. Yeah, I can see many experts have done it. Many of you kindly stay behind, although they're very good, but scroll around. Your attendance is appreciated. So I know it's very simple for many of you, but I just make sure that everyone on the same page. I'm pretty sure that everyone find it too easy, but I've catered for everyone, right? Left no one behind. Is it okay? Yeah, very good, very good. Sorry. Okay. So let me do the Q3 and then I do the IQR, right? Because 1 is Q1, 3 is Q3, right? So, and so that will be quantile exclude A2 up to A7, and then I do 3, okay? And the IQR is being Q3 minus Q1. Sorry. Okay, so supposed to be like that, okay? So because the data may be different from mine, but you should see this is the formula, right? You calculate quantile 1 and quantile 3, and then they take a difference. Any question? The quantile. Okay. The next is we want to calculate variance, right? Variance will be easy because variance, we have two things, variance.p and variance.s, right? One is divided by n, the other is divided by n minus 1, right? So it's rather simple. You should be able to see this is this where we are dot p, right? A2 up to A7, right? And we have VAR dot S, A2 up to A7. There's nothing new. It's just you can see one is divided by n, one's by n minus 1, right? And I just want to remind you, when you are doing a data work, you always do the VARS, right? Unless, as I said, if all the data you want, then the government, then you do the P, right? Otherwise, you're only able to collect some sample, that is the variance S. Okay, and that's the standard deviation P and SDS, right? SDP is STDEV, standard deviation P, A2 up to A7, okay? And I would do the same for the sample version. Okay. I trust you. You should be able to do coefficient of variation based on this. Shouldn't be an issue for you, but okay. I just go around to see if any question about these two. Of course, I'm pretty sure you don't have any problem, but I try to see if there are any. Let's just go around. It's very simple, right? So far, it's nothing except the quantile slightly different because you have two input, right? You have to put the data and the quantile, but otherwise, everything is just bracket the data, right? It's very straightforward, I would say, right? There's nothing very deep here. Okay. Now the three things remaining for the thing is like we have the skewness and kurtosis, right? Also mentioned is skew dot p here and skew the sample version. Okay. Actually, without my typing, you know the answer already, right? Just like skew dot p population 1 is A2 up to A7. Okay. It's negatively skewed for the data. For this one we have because why? Because look at here, last number is here. The mean is like 6, right? There's a lot of 1, right? 1 is like making this a problem. But if you look at the skew, then probably shouldn't be a big issue. So slightly bigger, but 0.3 probably not a big issue for us. Okay, but you know it's negatively skewed. Okay. Just to remind you that you will use the skew, right? Instead of skew P, right? Most of the time. Final one, we have a kurtosis, right? Kurtosis, right? It's KERT, right? Maybe I should write kurtosis, right? Otherwise, you don't know what I'm doing. KERT, okay? A2 up to A7, okay? So I hope now you can see how you can handle skewness and kurtosis. Is that clear? Right? Every measurement you can do computer, and the kurtosis we gave you is the one, the sample version, right? It's excess kurtosis, remember. I should be a little bit more careful. I should write excess kurtosis because this one is already -3. Okay. This is the sample excess kurtosis. Okay. So we just lose this one. Is here we have less than 0. It's negative. It means that we don't have a fat tail. It's a much thin, so we don't worry too much. Is that okay? Any question? It's time to raise a question if you have any. If not, okay. Then we go to the very last one. Okay, it's talking about we have the data is not single measurement, but rather we have multiple measurement, right? So consider the following data. Column 1 is GPA, right? Column 2 is wage, right? Say I make the example, we have someone who have a 2.5, right? 2.7, 2.3, I know 2.7, 3.2, 3.5, oh no, 3.5, 3.7, 3.4, something like that, right? And the wage we're talking about is this one maybe making this much, right? This much. Okay. So this is data. I make it up. Okay. Have no completely for no reason. Okay. Okay. This is data. Okay. So data is the wages for and the GPA. Okay. So what I want to measure is three things, right? Covariance, actually two things, covariance and correlation coefficient, right? And maybe I put it more funny. Okay. And you ask how he can make this, right? And his occupation is son. So he got his money from his daddy, so it's okay. Covariance dot P and covariance dot S. Okay, sorry. Okay. And we have correlation. Okay. So what we left is just this three formula and we're done. Okay. So this formula is very simple, just covariance dot P. Now have to be very careful here because we have two different columns. So you have to input this twice. Okay. First to tell them what the first column is, which is I will click A2 up to AX. Okay, the first. And then I need to input a comma to signify that I have another one, which is Y. Okay, as a comma to tell them actually you have the other one. So I would put it in this guy. Okay, so that is how you input to calculate covariance, is input the first all the X and all the Y. Okay, so that is the way you do covariance. This covariance P will be divided by N. Okay, so negative related, right? So the guy who don't study well will get a lot of money because of we have an occupation of an offspring, right? So, and with covariance, S will be this again, and then the comma there. Okay. And that is how you do covariance, right? And we have the last one, we have correlation coefficient is CORREL. Okay, the same idea. One thing, comma, the other one. Okay, and that's okay. So maybe we just make this guy more normal, right? So that would make you feel happier, right? Study more, get higher salary, right? Rather than other way around. Okay, so I guess that's the end for today. Although we have 3 minutes earlier, but I think sometime I have 3 minutes. Last time I have 3 minutes after, so I think it's fair to settle the class. So you're free to go. We'll meet you next week. I'll stay around to answer any question you might have. Have a nice weekend. I'll go around to see if any question, of course. Yes. 邊個嚟？我零係因為一要寫，因為佢寫係幾多個？咁如果少數點咪係嗰啲介意零點二嘅咪係話寫 round 翻得 round 個都係 round 得就合定，但 round 佢正常寫咪係 round。 I think the first one. I think you make more better. You know that I changed the first number to make it more real, but or less real. But if you change it to get the same answer, okay?